Beneath your feet lies a hidden world. Water pipes, electrical conduits, subway tunnels, even buried rivers. An intricate network shaping urban life yet deliberately concealed. Have you ever wondered why so much of a city's lifeblood is kept out of sight? In today's documentary, we'll explore the fascinating layers below ground, uncovering how these spaces were designed, who benefits from their invisibility, and what they reveal about power in urban planning. Some cities are now reimagining this hidden infrastructure, transforming it into valuable community assets. Let's dig deeper. The house that wasn't a house. In central London, rows of Victorian houses line the streets. But one stands out. Its windows never change. Its door never opens. This isn't a home. It's a fully operational electricity substation disguised as a residence. Across cities worldwide, critical infrastructure hides in plain sight using architectural camouflage. These facades serve a purpose. They conceal the mechanical guts of urban life from public view. This practice began during the Industrial Revolution. As cities modernized, residents objected to the visual pollution of new infrastructure. The Ladywell electricity substation in London, built in 1896, set the precedent. Its exterior matched surrounding homes while housing massive transformers inside. This approach, blending function with disguise, became a tradition that continues today in cities from New York to Tokyo. The motivations behind this concealment are clear. First, public resistance. People prefer infrastructure they can ignore. Second, property values. Neighborhoods maintain higher prices without visible utility buildings. Third, security. Disguising critical nodes reduces the risk of sabotage. Together, these factors created an unspoken rule in urban planning. The most vital systems should remain the least noticeable. New York offers a striking contrast to London's Victorian origins with its rooftop water towers. About 10,000 wooden tanks dot the skyline, resembling rustic relics. Yet, they're essential to the city's water pressure system, pumping water to upper floors and ensuring consistent flow across varying elevations. Their unassuming appearance masks modern engineering, blending necessity with nostalgia. Disguised infrastructure has evolved in creative ways. In Sun Valley, California, a sprawling wastewater treatment plant hides beneath what looks like a public park. Artificial hills conceal ventilation systems, while walking trails obscure access points. Similarly, cellular networks disguise transmitter antennas as palm trees, cacti, and even church crosses to avoid community objections. These designs show how infrastructure adapts to blend into its surroundings. This hidden network of systems functions like a city's secret circulatory system, vital yet unseen, quietly sustaining urban life. The psychology behind this concealment reflects society's conflicted relationship with technology. Victorians hid industrial structures to preserve romantic cityscapes while enjoying modern conveniences. Today, hidden cell towers reveal a similar paradox. We demand flawless reception but reject visible antennas. This tension extends to power plants dressed as office buildings and subway vents disguised as statues. Some designs go beyond camouflage to integrate infrastructure into urban life. The Smokestack Tower in Vancouver, for instance, appears to be both a historic chimney and a luxury condo. In reality, it vents steam from an underground district energy system while providing housing above. This dual-purpose design represents a shift. Buildings that don't just hide systems but incorporate them seamlessly. Not all disguises succeed. The Hampton pylons in Baltimore, high-voltage transmission towers shaped like giant men playing basketball, draw attention rather than deflect it. While technically hidden infrastructure, they've become landmarks, illustrating the limits of architectural deception when utility meets public art. The practice persists because it works. Studies show people tolerate necessary infrastructure better when it's concealed. A 2017 survey in Manchester found residents approved of disguised cell sites at nearly double the rate of visible ones. In Tokyo, research revealed people underestimated the number of hidden utility buildings in their neighborhoods by up to 80%. However, this concealment has consequences. When systems hide too well, people forget they exist until problems arise. London's sewer system, largely invisible since the Victorian era, only entered public consciousness during modern overflow crises. Similarly, disguised electrical substations face delayed maintenance and upgrades due to their low profile. Paris offers an alternative with its Wallace fountains, ornate cast-iron drinking fountains that serve public needs while enhancing street aesthetics. Rather than hiding infrastructure, they celebrate it as part of the city's character. This approach challenges the assumption that utilities must disappear into the background. Utility disguises reveal deeper truths about urban priorities. Cities spend millions making infrastructure invisible, rather than reimagining how it might integrate visibly into communities. These choices reflect who holds power. Planners favoring property values over transparency, companies preferring discretion over engagement. As we'll see next, some infrastructure hides even deeper, buried beneath streets rather than behind facades. Rivers beneath the pavement. Beneath Fleet Street in London, you can still hear the River Fleet if you listen carefully near certain drain covers. Once a major waterway wide enough for boat traffic, it now flows through brick tunnels buried during the 19th century. Cities worldwide contain similar hidden rivers, waterways that shaped early settlements but later became obstacles to urban growth. London sealed the Fleet to combat disease, as industrial waste had turned it into an open sewer. Many urban rivers met similar fates during industrialization, when cities prioritized expansion over environmental concerns. Seoul's Cheonggyecheon stream offers a striking contrast. In 2003, engineers removed a 16-lane highway that had covered the waterway since the 1960s. The $281 million project created a 5.8-kilometer public park, lowering local temperatures by 3.6 degrees Celsius and improving air quality by 35% along the corridor. Property values nearby rose by 25 to 50%, and the restoration reduced flood risk by increasing stormwater capacity, an essential adaptation as climate change brings heavier rainfall. The revitalized stream also became a cultural hub, hosting festivals and drawing millions of visitors annually, which boosted local businesses. Buried rivers present modern engineering challenges. Toronto's Garrison Creek causes flooding when heavy rains overwhelm its century-old diversion tunnels. Engineers found the creek still follows its original underground path, exposing weaknesses in aging infrastructure. Similar issues arise in Montreal, where the buried Rivière Saint-Pierre destabilizes building foundations and complicates new construction. Historical maps are now essential tools for cities to predict and mitigate these risks. The decision to bury rivers often reflected shifting urban priorities. New York paved over the Minetta Brook in Greenwich Village to create more buildable land. Chicago reversed its river's flow in 1900 to keep sewage away from Lake Michigan. While these measures solved immediate problems, they created long-term consequences. Chicago's river reversal, for instance, spread industrial pollution downstream, affecting communities along the Mississippi. Climate change has made these hidden systems even riskier. London's Victorian sewer network, designed to handle the Fleet and other buried rivers, now overflows about 60 times per year, dumping untreated waste into the Thames. Tokyo addressed similar challenges with the Metropolitan Area Outer Underground Discharge Channel, a $2 billion system of tunnels and reservoirs capable of holding millions of tons of floodwater. Some cities are reconsidering their buried rivers. Zurich daylighted several creeks in the 1990s, creating urban wetlands that manage stormwater while providing public green space. Los Angeles has studied restoring parts of the concrete-encased Los Angeles River, though costs remain a barrier. These projects often face opposition from businesses and residents occupying the land above buried waterways. The physics of buried rivers explains many urban flooding patterns. Water follows the path of least resistance, often retracing original riverbeds beneath pavement. Toronto's flooding maps, for example, closely match historical waterway maps from the 1800s. Engineers increasingly rely on these old maps to predict which neighborhoods will flood first during heavy rains. The process of burying rivers wasn't always carefully planned. Cities often expanded over small streams without formal drainage systems, as seen with London's lost rivers like the Tyburn and Walbrook. This haphazard approach creates maintenance challenges today, with pipes following the winding paths of forgotten streams. Occasionally, construction projects uncover remnants of these waterways. Workers digging London's Crossrail project found Roman-era wooden structures preserved in the Walbrook riverbed. In Edinburgh, crews renovating a shopping district discovered an 18th-century bridge buried beneath the site, evidence of the long-covered Nor Loch. These finds highlight how thoroughly cities can erase their waterways. Economic factors often determine whether a river stays buried or gets restored. Seoul's Cheonggyecheon project succeeded partly because it boosted nearby business revenue by 300%. Zurich's daylighting efforts increased property values along restored creeks. However, with urban land at a premium, many cities struggle to justify removing valuable real estate to expose waterways. Some buried rivers retain cultural significance. London's Fleet appears in Dickens' novels and Hogarth's paintings, preserving its memory even as its physical form disappeared. Melbourne's underground rivers feature in Aboriginal Australian creation stories, connecting modern infrastructure to ancient landscapes. These cultural ties sometimes inspire preservation efforts where practical concerns don't. The future may see more rivers uncovered as cities prioritize flood control and public space. Rotterdam's water squares combine flood basins with recreational areas, offering a model for multifunctional water infrastructure. As climate pressures mount, the rivers we buried may resurface, whether we plan for it or not.